Define, the paper is topic is current of electricity, June 18, 21/6. Define the volt. So actually, volt is joule per coulomb. And when you have to define a physical quantity, you have to write 111.
So can I write a volt is joule per coulomb?
You can write joule per coulomb, and you can say, but you need to make a definition for 111. The definition will be related with the 1 volt. You can say if 1 joule energy is transferred to drive 1 coulomb charge, the voltage is said to be, or PD is said to be, 1 volt. So that would be the definition. A battery of electromotive force 4.5 volt and negligible internal resistance is connected to 2 filament lamps P and Q and a resistor R. The current in lamp P is 0.15 ampere. The IV characteristics of the filament lamps are shown. So you have to see the circuit, and if you have opened it on a parallel device, you can easily see the diagram. The lamp, there are 2 lamps actually, P and Q. So the current in lamp P is 0.15 ampere. The current, because they're in parallel, so in parallel they will be having separate current. The IV characteristics of filament, but they will have the same voltage. Whatever the voltage is, in parallel, voltage is always the same. Use the figure to determine the current in the battery. Explain your working. So you have to tell the examiner that in parallel, PD is same. Current divides and conserved. So we make the point, and then he says, the examiner says there is a 0.15 ampere in P. So 0.15 ampere. So 0.15 you have to locate and read it on the y-axis. The current is 0.15. So read it for P and then read it for Q. So you have to make a line from here.
So it's 2.
So I have read it for P and now I'm reading it for Q. Point 0.09. 0.09 and 0.15. Now there are two currents. So it is having 0.15. It is having 0.09. And they want the total current from the battery. So there is no internal resistance. So the total current will be 0.09 plus 0.15. So see this working? So what is the answer for this?
Sorry, sir, I got disconnected.
No problem. But the current is 0.24 ampere.
Yeah, I got this amount.
Calculate the resistance of resistance R. We know the total current in the circuit. We have the total current value. Calculate the resistance of resistor R. We know the current. Now, how can I settle this value? So either I go for voltage division, or if I know the current and I know the voltage, I can find the total resistance. So now make a plan and let me know how I can find the resistance. I have the data and I have a graph also. You can see the graph. The graph is ready to give me the voltage across the lamps because obviously the lamps are in parallel. If I get the voltage across the lamps, I can subtract it from 4.5 and I can get the voltage which is coming for capital R. Once I have the voltage, I have the current, I can find the resistance. So this would be the plan. Somehow I'm having some problem in connecting it down, but you can connect it and you can precisely read it.
Yeah, it's giving 2.7.
It's getting 2.7. So you will tell examiner that 2.7 volt across the lamps. So 4.5 minus 2.7. See how much it is? How much is 4.5 minus 2.7? This is the thing we need to find. We can find the resistance using this equation. So let me know once you get the value of R.
I got 7.5.
Hmm?
7.5.
I'm sorry, 27.5. Are you getting, you're saying 27.5?
No, 7.5.
Okay. Now read the next part. The filament wires of the two lamps are made from materials with the same resistivity. Resistivity is the same at their operating temperature in the circuit. The diameter of the wire of lamp is twice. Diameter has a ratio of double. Twice the diameter of the wire of lamp Q. What's the formula for ratio of resistances? We can recall the formula first. We need the ratio of the length. But first let's see the formula. R1 upon R2 is equal to L1 upon L2 into D2 upon D1 square. Let's suppose that P is our 1 and Q is our 2. I am looking for L1 upon L2. So I will make L1 upon L2 the subject. Now, this is the equation. So now R1 upon R2. Any idea how I can find the resistance ratio? I don't have a resistance of P. I don't have a resistance of Q. But I know that resistance is equal to V upon I. Remember, P and Q are in parallel. So can you now tell me how to tackle this R1 upon R2? V upon I1, V upon I2. I replaced it for my next step, D1 upon D2 square. V and V will cancel. If you have joined back, you can look at the steps I have done. And if you have any query, you can ask. And we are making a ratio L1 upon L2, I2 upon I1, current Q upon current P. Q was having 0.09 upon 0.15. D1 upon D2. You see the diameter of the wire P is twice the diameter of the lamp Q. So it will be 2x upon x whole square.
So that'll be 2.4.
Okay. See the whole working because you had a disconnection. So you can look for the whole working and see the final ratio.
Yeah, I got it, sir.
Now this comes the theory question. Theory questions are always very important because they set your label for the examiner that you are a smart student or not. The filament wire of lamp Q breaks. The filament wire of lamp Q breaks and stops conducting. So Q is gone. State and explain qualitatively the effect on the resistance of lamp P. I always prefer, but this is obviously the time is very short. But normally, I always tell my students that you have to use examiner report when you are answering this theory question. Normally, people focus on the. Normally, people focus on the marking schemes and they just leave. So as a reference for our exercise pattern, I am opening the examiner report. Candidates found it. Look the part number 4. Candidates candidates found it difficult to explain the changes in the circuit due to the filament wire of lamp Q breaking. The majority candidate assumed that the PD across P would not change and stated that the resistance and current were inversely related. Only a very small number, just one. The majority, only a very small number, stated that the increase in current P would cause the resistance of P to increase. A smaller number stated that PD across P would increase. Now, if you have read it, we can go back to the question to reconnect our discussion. And examiner says Q has broken. So it means Q is gone. So if Q is gone, look, the wire lamp Q has gone. If Q has gone, the lamp P and the resistor R are now in series, because it should be now imagined the circuit is like this. The resistor R and the lamp P, they are in series. Everything else is the same. Now, if you draw it once like this, then you can well understand what is happening now. As soon as the P has gone, Q has gone, only one lamp is there. There's no parallel combination is there. So what will happen to the voltage distribution? The resistance of R, we haven't find it, the resistance of lamps, but we can now guess here what happened.
So
Resistance
the PD increased, which caused the current and also the resistance to increase.
Now, this is a point correctly that actually once only one resistor is there, the voltage across P will increase. P and Q were in parallel. P and Q were in parallel, so their resistance was less. After the blown up of Q, P is alone. Now P will get more voltage along with the resistor. So as the voltage across P increases, what will happen? Definitely the circuit will be overloaded and temperature will increase. Due to increase in temperature, resistance of P will increase. These questions actually are the game changer. Whenever you are solving these questions, you have to give very good attention, because these questions actually set up a level for the student. Now we have June 18, 226. June 18, 226. State Kirchhoff's first law. Kirchhoff's first law says that total current entering a junction is always equal to the total current leaving the junction. Kirchhoff's first law is linked to the conservation of a quantity. Which quantity is conserved in first law? That is again a memory question, that is charge. A battery of electromotive force 8 volt and internal resistance is connected to a resistor X and a wire Y as shown. Okay, now read this question and I'm just coming, I have to say Asar Namaz. So you please start this question and we'll discuss it after the first part. You can any formula of energy. EMF is 8 volt, internal resistance is 2. He's talking about the battery.
Yeah, so you can use I square as 2.5, then the resistance as 2, and multiplied by the time.
And time is in minute.
So you convert, multiply by 60.
Yes. The thermal energy dissipated in the battery in a time, so energy is equal to we have the current 2.5.
Yeah, 2.5.
So see how much we get on this.
You'll get 3,750, which will be 3,800.
The terminal PD of the battery.
We can use the formula R equals to V divided by I. So V equal to IR.
So
And
terminal,
we'll get
what is actually terminal PD? It is the PD which is available for the external circuit. Which is available for the external circuit. It is not internal PD. So you
but
can.
you have to minus it from 8, right?
8 is the EMF. So you need to know how much battery itself is eating up.
So we can do 2.5 times 2, V
So
equal to IR.
It is the available PD. And how we find it? It is obtained by EMF minus internal PD. This is how we find it. EMF minus internal PD. So this is how we show the working. So what is the answer for terminal PD?
Answer will be 3.
Determine the resistance Ry. PD is the same for in parallel. So I should first try to find the current in the 15 ohm resistor. I can use Kirchhoff rule. I say it is I1 and I say it is I2. How I can find I1? 15 ohm is the resistance.
So 3 divided by 15 because 3 is the terminal PD.
Right. So you will tell examiner that PD is same in parallel. So I1 is equal to V upon Rx 3 upon 15.
So that will give 0.2.
Then I1 plus I2 is equal to 2.5 ampere. So how much would be I2?
2.3. After this, we can just use R equals to V divided by I. So again, 3 divided by 2.3.
Right. V is the same.
So we'll get 1.3.
1.3. Okay. 1 point. It's a very small number. A new wire Z has the same length but less resistance than wire Y. State 2 possible differences between wire Z and wire Y that would separately cause wire Z to have less resistance than wire Y. What are the factors which control resistance? Resistance is proportional to length, inversely proportional to area, and resistance depends upon resistivity, and resistance depends upon. So these are the 4 factors. These are the 4 factors of any resistance to work.
So we could increase the Z has a bigger diameter.
Right. because length is same. So length option is blocked. So the first possible reason is the same material or different material. No, he has not mentioned that. We can engage material also. So that is fine. You can say cross-sectional area or diameter. Less resistance than wire Y. So it means Z would be thicker.
Sorry, sir, could you repeat?
Z would be thicker. As you said, the diameter approach. Now, what about the second difference? We can engage resistivity, I mean material. For example, Z has less resistance, so maybe it is a material of smaller, of greater conductivity. Majority people remember that resistance depends upon length, resistance depends upon area. Many people remember resistance is a function of temperature also, but there is another feature, that is resistivity, material. Obviously, if I have a copper rod and I have a silver rod, copper and silver, gold, iron, they all have different resistivities. Wire Y is replaced in the circuit by wire Z. Okay, wire Y has less resistance. Where is wire Z? Wire Y has less resistance, less energy loss, less power dissipated on wire Y. Oh, sorry, wire Z. So it has less resistance. Less resistance means it will dissipate less power. So you can see here, that is the battery. This is wire Y. I am replacing wire Y with wire Z. Examiner says that Z has lower resistance. Lower resistance means greater current. So what will happen? Current will increase. So what will happen to the battery current? Battery current or power? Just a So you will tell the examiner that Z has lower resistance. It will invite greater current. Then power is equal to I square R. So power increases. So power will increase. So now we have done this question, and we will do it inshallah. In the next class, we can select a new topic. Now we have done 2 times the questions on current.